So we're going to talk about Project Reactor, or as we sometimes call it, the Flux, because it's one of those methods within Project Reactor. But it's a much easier word to remember. So sometimes in this talk I will mix up Reactor and Flux. It's just a matter of habit. You will get used to it. So, small introduction. I work for ING. That's a big bank in the Netherlands. They're also here in Poland, nearby actually in Katowice and in Warsaw. We're in Belgium and many other European countries. In the Netherlands, we're the biggest bank. So within that bank, I'm a software engineer, and I'm part of a squad that's called, or sometimes referred to as a team, Blanco 3MO. And what we're doing there is that we're working on an application platform that's called the Message Center. What Message Center does is that it, there you go, in a stateless way, we'll receive a request to send a message to a customer or about a customer, and then store it in the archive or deliver it to their home address or to their inbox or email. And all of this goes through different hoops where we validate, we make decisions, and in the end, you will get a good result there, which sounds quite complex, and it actually is. As you can see here, the yellow block, that's our application chain and scope. We have 4 minor blocks in there, and they used to be microservices. However, we didn't see any benefit after a while. We were planning to put more services in for the delivery and for the orchestration part, but that wasn't necessary, so we scaled them down to 1 application again, and just picked up the modules, put them in 1 API that's now available. However, the difficult part for us is all those little circles, because depending on what kind of message you have and what kind of enrichment we do, if you come in with a bank account or a mortgage number, we'll pick up all the customers needed to be reached and checking out if it's possible to actually reach them. So depending on the input, we'll touch maybe 1 or 2 or maybe even 6 of those circles. And some of those will take a longer time. This is all I/O, and as you might guess, in the reactive world, that really has a benefit for us that we can more efficiently handle that also towards our customers. So we end up at Reactive. We used to have this in completable futures in Java, which is quite nice if you do all those remote calls, but just those calls were made reactive by us. Then we migrated to Spring 5. And Spring 5 has a nice option to use Project Reactor as a full reactive layer, along with Web Flux. So if you look at Reactive, I could put the image in here, but most of you hopefully already know it. Handles about the responsiveness, the resilience part. It's message-driven, and as you might guess, we do handle messages, so it's a very clear thing to do, and it's elastic, so it's quite scalable. We also want to look into containerization, because we're stateless, we can easily scale up. So if it's not too many messages being sent, you just use 2 containers. If you have a big batch coming in the evening or on a Sunday to send all the paper stuff the next day, then at that point you can scale up to have a lot more instances to handle the loads. So, sounds good, we should do it. The main difference we have here is that it's all, those are events. It's reactive, and you process those events, those messages as events through your chain until you're done, and then we also report it back. So if there's a connecting service within ING that wants to send a message, we'll also report all the way back after a very short time or a long time, if it takes longer, what happened to that message. So they will know what to do. If something failed, they can actually decide functionally to do something else with it. Like try again, but also maybe call another process, fix it, and then try again to have it resolved. Well, as mentioned, we're using Project Reactor. Before this, we used the completable futures, which are quite nice. If you don't have this, if you don't have Spring 5 or any other reactive framework, it's a perfect solution, but it is a little bit less readable. And for that, we also went to Reactor, because it's much more like reading a story if you're reading the code. That's clear to developers and much more easy to build upon. And to add it, if you have Spring 5, then just add this library or one of those other 2 if you want to do some extra testing and want to use the tooling. I will get back to when you can use those later on in this presentation. And you're set, which all sounds quite good. The why and when. I already dipped a bit into that. The why is, you could see we have a long chain with a lot of stuff happening going on. Sometimes you do shortcuts, sometimes you don't. We have some events that are sending a notification to a phone with pre-formatted text. Those are just flying by, you don't even see those. We also have people sending out letters with multiple pages, like this stuff ending up in a letterbox somewhere. At that point, it will take much longer. So if all those come together and you do a standard threaded model, after a while you start locking up because of all those blocking messages. That's the part where the reactive processing of messages to us is quite a big benefit. So when do you do this? For us, it's mostly the blocking calls. That's really the most important part. We don't really care about the asynchronous part. It is, of course, quite a good part about reactive. But for us, the non-blocking was the real reason we chose this solution. And that's another thing. If you already have an application running at 100% CPU that uses all your memory already, there's no benefit in using reactive. You should first look at getting more machines, getting a faster CPU, etc. Which was not the case for us. We're running quite efficiently at the moment. In production, our peak levels for CPU are between 26 and 28%. And that's happening maybe once a month. And of course, back pressure is quite an important part about reactive. If you want to tell someone calling you all the time, slow down, I cannot handle it, that's where back pressure comes in. We don't really use it yet at the moment. We do have a Kafka topic to handle this. So we can actually say, okay, I won't consume the messages for now because I'm just too busy. But there's only 3 parties using it at the moment, and that's not enough. Most of our communication is done by REST calls, on event, on API, and back. So this all sounds quite good, but well, there are worries sometimes, which is also the title of this presentation. And worries are fine. It's very natural behavior to handle the unknown, or sometimes the known challenges that you will face. So you can sit down, you can walk away, but you can also look at them. It's not fear, you just see something, okay, this might go wrong, or we might have an issue here. Let's start looking at it and let's start solving them. So one of the issues that we saw when we went over to the reactive world is you will complicate your code. Before you just had a straight line that's calling all those actions, and then you know where you are if you need to look up something. That, when you do reactive, suddenly changes because instead of maybe 30 threads at once, you will have a lot more. We can go up to 255 at once. And figuring out what went wrong where, it will become a bit more complex. And also because you have to rewrite all your calls to those methods towards the Flux assembly, which I will get back to in one of the following sheets. The readability changes, which is not per se a bad thing, but if you're not used to it, you will have some slight struggles there. Another issue we had is, will it perform well? Because why do we migrate towards this? We want to see a good performance. We did see already that our servers that we had were limiting themselves. When we didn't do it, that's why we went to the completable futures, which resolved a lot of issues for us. So most of this worry was already managed. And like I just mentioned, in production, we have up to 26, 28% as a peak. And for us, that's fine. That's perfect. We don't even need to add more machines. We suggested lowering the amount of machines, but that got some people scared, so we didn't. So I won't talk about that part in this presentation, but it was one of the worries we had. The other one we had is like you're having developers, and sometimes stuff breaks. So how will you start testing that it does what it should do? Is there enough tooling for this? Does our IDE handle this efficiently? Won't I spend more time digging into the debugger, like what went wrong, compared to the solution we already had? So I will also cover that part quite extensively, how we resolve that and how we managed to quickly identify and resolve issues we found. And of course, always important, if you do a new technology stack upon your code, you may get that some people either are new or don't know about it or know a competing framework. So how do you manage that this knowledge and skill set is quickly transferred towards them? That's also one of the reasons I made this presentation. So going to the reactive framework that we're using, there are basically two types, mono and Flux. And we're always calling it Flux because we're doing a lot of things with arrays, then that's typically the object that you're using. You have uni and multi in Quarkus, I think, as a solution. It's just a different name for the same type. Mono is single, and Flux is a combination of a lot of elements. It's a stream. We also did a lot of things with Java streams beforehand. And when you get a new colleague who's used to that, and you have to explain it, you just say, OK, in streams, you just pull it. So you keep on asking, hey, give me more. And within the reactive solution, you get them pushed. They are produced for you. You're consuming them. We are both producing and consuming with the Flux and the mono, which sounds a bit odd because they're publishers. But what we do, because we have a lot of those things in a chain, is that one call with a mono or Flux will end up in another call with another mono and Flux, end up in another mono and Flux as well. And that for the parts that we need. So sometimes our chain is 2 elements, and sometimes it's 5 or 6 or even more. And what happens at that point is once we consume it, we'll start a new producer with another mono or Flux. So you can go from Flux to a mono and back. I'm not going to go into too much depth of the project Reactor itself. There's great documentation on the web. There's also a lot of good presentations about the subject. So if you're looking for those, I would say check up YouTube, get one of the latest ones of the last 2 years. Those are really up to date with the framework. And of course, the documentation. Whenever I need to find something, I just go to the Java doc on the website, and it's perfect because they clearly explain how stuff works, what methods you have, and those are extended quite often. They're still working on a framework, which is quite good because you get a lot of new functionality over time. So, how do they work? You start with the assembly phase, which is basically you stream stuff in. You do something with it, like in this case, we just log it, which is a great debugging feature. But you can also filter it, you can map it, which is very identical to what you do beforehand within the Java streams. And as you can see, there's a small brownie. And it has to do with nothing happens until you subscribe. So you can assemble all you want, but nothing will happen until you start consuming those messages. They're just waiting for you to subscribe. And how do you subscribe? Well, that's what you have subscribed for. And you can actually do something with the result coming out of your either mono or Flux. Along with that, we also have schedulers, which is a way of determining which threading model will you use. So are you using your current thread, or do you want 10 threads to work on? So the easiest one is single. It's just one new thread, make one for me, and I will start working on it. There's parallel, which we usually use for short calculations. So if you just do calculations, give it back to me, then a parallel is fine. And that has to do with a parallel maximizes in threads on the amount of CPU in your machine. We did have an issue with this because our laptops are quite fast. They have a lot of threads physically. And one of our test environments only had 2 CPUs in it. So we didn't encounter issues, but we did see different results suddenly. And that had to do with a different amount of threads popping up for the parallel part and also for the next one, which is the bounded elastic. And I put bounded between hooks. However, if you use one of the latest versions of Reactor, they tell you stop using elastic, use bounded, which is basically the same, but it has an upper limit. I think the elastic part goes up to 256. So if you don't define it, it can be anywhere, which can give some unexpected behaviors, even if you only have a few physical threads on your machine and CPUs. Another one we don't actually use is immediate, which is just basically saying, I don't care if you have a new thread, just use my current one and start processing here, which is the same as single, with the difference that single makes a new thread pool for you with one thread. So the interesting part, if you start working on Reactive and with Project Reactor, is the exceptions, because they don't work as you expect them to. But if you look at this great picture, then you will see there's a lot of chaos going on. And as you know, as a developer, there will always go something wrong, and You will sometimes have some side effects that you don't expect. And that happens here as well, because if you want to drill a hole, there's no drill available. Not to mention that there's a lot of other stuff around that might interfere with what you're actually trying to achieve. So when to catch what? That's a good question. Mistakes happen. And then you're waiting for an exception and nothing happens. Your processing just stopped. That's the first thing we encountered when we just switched to reactive. Wait, something broke and we only had 2 messages processed of the 10 we sent? How did that happen? Because there's no classic stack traces. It's just a signal coming along, either saying I'm finished, which is good, or I had an error. And at that point, you should do something with it. So our first attempt was, let's just do an error that looks, that's the first one you will find if you scroll down on the page. Let's use that, it looks wonderful. It will still stop after those 2 elements that breaks, and it will log what happened because that's what you put in there. But it still won't continue. And if you look at our use case, we don't want to stop processing the rest of the messages. If I have 10 requests and 1 is failing, I do want to process those other 9 requests, because those might be fine. One issue that you should be very careful about, if you do any error handling, don't cause another exception within your error handling, because that's hell to discover. It happened to us twice. And of course, after the first time, you know about it. But the first time, it took us about half an hour to figure out what the hell is going on. It should work fine. It turned out we logged a piece that was null and did an operation on it. So what should you do if you don't do an error, which is just basically an aspect that says, OK, if an error occurs, do this for me, is that you should resume or continue. There's also a third option to return at that point, but you can do some extra stuff in it. But for our case, we do want to continue. We do want to process all those other messages on all those other events within our chain. So the thing about resume is it allows you to replace what you should have sent at that point, which is what we use most of the time. And why do we do this? Because we have all those steps, we've collected information about the message that we're going to send. Information that might be vital to resolving why something failed in your application. So once an error occurs, we pick it up, we pick up all the data, log it, and then resume to the next request within the Flux. If you use continue, we just ignore it, and you pick up the next one. We do that at 1 or 2 locations within our application, because at that point, we don't care what the content was. And as always, this is quite complex. It really depends on what your application should do, what you're trying to achieve. And for you, you might have to choose another option. So what works well here is that you build a test around what you're supposed to do and verify that it's actually working as it should. So for all these cases, if you have a complex part, make more tests. That's basically what works best. Try to make the processing small. But when you do get stack traces, this is another quite nice one, because there's no way you can relate, a mono broke. OK, we have hundreds of those. Where is it? So you can log around it and try to figure out what it is, but that's not doable. That's old school debugging. But there's a good solution for that. And if you look on internet, you will find that people suggest hooks operator debug is a good solution, but please don't. What it does is that it always keeps up your stack, even if everything is going well. And that's, of course, costing resources, and that's what you don't want, because you want speed and you want efficiency. So if you add the Reactor tools package, you get the option to do Reactor debug agent.init, which is running in the background, but it only will fire once a stack trace occurs. And the result of that, of both those operations, is this. This is actually one from acceptance in our own application. Something broke. But as you can see here, I get a full stack trace. So I know what went wrong, where it went wrong, and how I could solve it. And that's a good step up to debugging. You can use log, because that's usually when I get a new colleague, I will tell them, just add log. You will see what happens with that mono, with the Flux, where you are, which values you passed on. But if you're more advanced and you want to debug some code that you had and you build a test set around it, we typically use the checkpoint, because in the checkpoint, here you can see I added a string, but you can also add variables and print them to a string, which are then logged to your log file. These are quite useful if you're running a small subset in a test. And well, as suggested here, just use, we have a lot of external services. So what we do for all those services is we build a lot of mocks with MyMock, load them in. We have timeouts in there. We have wrong messages in there. At that point, we can easily replay what went wrong and also resolve it. And for those parts, we also then add a checkpoint to see just in case, or we just combine it with a debugger. And IntelliJ has quite a good debugger option for this. If you forgot to tag it the Reactor debug mode, just find it in the settings and enable it there. And talking about testing, there's JUnit. We're using JUnit 5, but along with that, we use the test package, as described in one of the first pages. This allows you to set up an assembly, add it in, and then check every step in it, what happened. Did I have an error? Did I have the right signal? Is my data here? You don't need to subscribe at that point. You can just add the Flux in there, and you can process it at that point. Also allowing you to make very fine-grained tests that allow you to find those specific errors that you're looking for because you had them in production or on your acceptance environment. One thing we ran into a lot was that we didn't use Block all that often, and you should, because Block is also a subscriber. It will just wait until you're done, and at that point return the value. But if you don't do that, your test will run, and it will be over because nothing happened at that point. It's still running in the background, and your test will fail, because the data you're testing for is not there yet. It might be there in 1 or 2 milliseconds, but it's not there yet, which is quite a challenge. So what do? You add thread.sleep. And it runs fine on your laptop because your laptop is fine. And then you go to your build environment and it's much slower. So you add a longer build time or longer sleep time, which is good if you only add 1 thread.sleep. But after you add 10 or 12, things start to add up. You really don't want that. So if you can, go for a .block, which is just done by when the method returns a Flux or mono. You add it there and you can get the result back and process it for your testing. Something to keep in mind, and there was a great talk on Wednesday by Mike Kowalski, I think, about the JUnit 5 and multi-threading, parallel running, parallel testing. By default, I wish I had seen the talk earlier, by default, the JUnit test runs on 1 single thread. So what works well in your test? We had one moment where we were trying to resolve an issue, multi-threaded. The test was wonderful, cool, let's bring it to the test environment and test it for real. Stuff broke, because at that point we had real threads and multi-threading. The lessons we've learned while doing this, so just going from a normal processing done with some minor reactive stuff within Java, is one of those things is, when do I map or flatMap? Because you're used to that from Java itself, from the streams. And it's quite easy to remember, actually, because map is synchronous. It's all done in order. And for flatMap, you have an asynchronous processing. So if you receive a Flux, you can do them synchronously or asynchronously. And what we use is the flatMap sequential, because we do want them to be back in order at some locations. And I think for the requests themselves, we just do them asynchronous. Just give me the request return and I will process it, because then you don't care about the order. These two are quite important to remember, and that's one I always take to new colleagues, like, please do pay attention to when to use flatMap sequential. It does add a lot to your performance. There's this senior guy who's getting used to the future. Do not rely on your old thread knowledge, because that is an issue. I already talked about thread.sleep, but Reactor and Project Loom upcoming, I hope soon, with its fibers, which are as I always explain them, kind of sub-threads. They're not real physical threads, and you can have hundreds of those. They don't follow the Java thread pattern. So if you think you have your thread stuff, it sometimes works a little bit different. Don't forget all, but do keep in mind that the model is different. Thread.sleep is one of those. And yeah, like I said, old habits die hard. You do see people doing it. Even I did it a couple of times. However, one of the main issues we had was thread local. That's not in our code. We're using a library that's called tracing, that does traces of what APIs did you touch, which usually looks like this, if it shows up. Come on, there you go. Which is great, because you can see which service did I touch, which components did I touch, because we also use this within our own chain to determine which part was I touching, what went wrong. And as you can see here with the orange part at the bottom, that's something that was a warning, so you could continue. You also have red markings that something completely broke. But if you have a broken thread local, you will only get one of those lines each. So there's no way to use this anymore. We resolved that by working around thread local and overriding the value that the tracing package is using. So even if your own code is perfect, reactive-wise, you can still run into issues from other libraries that you're using. And well, you have subscribing. And sometimes you forget about subscribing. And as people on YouTube always tell you, click that button, subscribe, subscribe. Don't forget to subscribe. It is, however, very easy to figure out. So once you have a colleague that's built some code, he's like, nothing is happening. My code looks perfect. The assembly is fine. Then always ask, did you subscribe? Sometimes you get it for free. So if you use Flux, then the subscribe is already on the call that you're doing and returning. But if you're doing some separate code, like in a test, then please, please, please do subscribe. Otherwise, you spend a lot of time figuring out what went wrong. Another interesting part is, should you Flux or reactivate all the things? Because initially, we had this whole chain, all our I/O calls that were taking up time and resources. We put them in completable futures, which was working at that point fine for us. But if you're using reactive and Flux calls, then it makes also more sense to complete a chain. All the calculations done in between, which are quite fast, it doesn't matter, you can still combine them to one big Flux that's all running through the application with multiple methods. Because sometimes you do one part, and like I mentioned, sometimes we have two, sometimes we have up to 6 or 8 calls chained together. And yeah, the main benefit that you get is if you make everything reactive, you will get more performance and better efficiency on your machines. The thing is, you should test it if it actually matters for you. So one of the things we mostly notice with colleagues that are new to the reactive programming is they get a list and then I just return it in a mono, and someone else downstairs will pick it up and it should be fine. That's a good indication that maybe we should look at it if we can improve it. It can be perfectly fine to do it like this. No one is telling you to make everything reactive. And the same applies to a lot of .just all over your code. That means your chain is broken, which can be fine. But if you want to write one chain, look at those and try to resolve those. Because as always, do stuff that adds value. Don't do stuff because someone told you we have to Flux everything, or we have to use this new technology because it's cool. We should use it. Add stuff because it adds value for your application, for yourself because it's nice to learn something, or for your boss because he can order less machines and go to his boss telling him he saved money. And if it doesn't work for you, then don't do it. But of course, always experiment and try out these kind of things. What we also ran into was when we started migrating towards reactive, is that our code was all based on, we had methods and we had 4 modules and they're talking to each other, and sometimes you end up there and sometimes you end up there. This works fine if you can click through the code from a method sense, but if you add everything to a Flux, then it's just a step in the assembly, and there's no longer a clear overview of I'm calling these functions in this module. That is happening. So what we ran into was our code needed some restructuring. There you go. So what we did is that when we copy-pasted filtering, for instance, usually you would just have your code in there. What we did is we put it in a method, and then the methods give it a cool name that would explain what it would do. Like, does this contain this value? And then true or false back, instead of copy-pasting that code into the assembly part. Because if you have a very long Flux with a lot of assembly, it would become much more difficult to read. And code should read like a story, so you understand what's going on. And that's another part. If you do a lot of chaining, like we did, so you have a lot of monos running into a Flux, running into a mono in this case, and in the other case, a Flux comes out, stuff can become quite complex quite fast. So do try to limit the train length. A couple of years ago, I was on a project and we always talked about train wrecks, which were methods calling a method in another module, and back and forth. And then something broke and you had to figure out what went wrong. If the train gets too long, you lose your sight of it. So try to keep them as small as possible. And what we did here is make small modules that make sense from a business case, a use case perspective. Already mentioned a little bit the method naming, because you want it to read like a story, the assembly part. Sometimes you also have to change those, so it's clear to everyone what's going on in this Flux. Otherwise, you just see a lot of lines, maybe 8 to 10 lines that's doing stuff, and yeah, I lost track halfway. You don't want that. Another great tooling we had, and that quite well helped us, is BlockHound. That's part of the Reactor project as well. And what it does is you add it to your code, and it will start blaming you and trying stack traces when something breaks. And those are actual stack traces, so you will see them in your log. This is one example of it. As you can see, it's a real-world example about someone who forgot to remove a sleep in one of our tests. It will notify you, stop doing this, improve this. You can make a Flux there, you can block it, and at that point, you're fully reactive non-blocking, because, as I mentioned in one of the first slides, to us, the non-blocking part was the most important. We don't care too much about the asynchronous part, but all that blocking, all that waiting for a response, that's an issue. To add it, just add this dependency to your project, and you're done. The downside is it will always run, so after a while you start commenting it because you still have some code left that you need to fix. Recap. I did mention some issues we had, or worries we had, basically, like the complexity of the code and the operations that you're doing. Some of those we picked up by restructuring code. Pick better names, ping-pong less between modules, and also make a lot of test cases extra. So before we had larger test cases, we made them smaller. So if you had one test case before, you would end up with 3 or 4, being much more specific about what was going on. Clarifying also to the developer, something breaks, then it must have been this part instead of something within this big test case. The performance I mentioned, that was quite good actually. We were already quite used to it, so it wasn't really a big worry. It's something you just write down, okay, we should take care of this, and is it an issue, yes, no. If you don't have this yet, I would say make a baseline test on your existing code, start hacking away with a proof of concept, and at that point test it again to see what the performance is. For us, it was really a big benefit because we had a lot of blocking calls. We just have calls to APIs, to remote services, but if you do database calls, if you read files, at that part you will truly see a big improvement on your performance. And not just in speed, but also in memory. The debugging part, that wasn't too much work actually. Most of it was trying to figure out how to fit in those step verifiers, because you just tell them, this is my assembly, I expect this to happen, show me if that's true. Basically, you're proving that your work is done. And once you get it up and running, then you're set to go. The main change we did there was that most of our functions didn't immediately return a mono or Flux. So what we did is rewrite some code, make it smaller, and at that point test that smaller code with the specific test in step verifier. And like I mentioned, don't forget the thread sleep. Really try not to do that. It's easy to, okay, I can test it like this, and it's working, but it doesn't feel right in so many ways. And your test line run much longer. So then the other part is how to share this to your new colleagues or to colleagues who are very used to the old way of working, because reactive is a different mindset. You really have to get used to that there's a promise to give you an answer and deliver the message to you instead of just, okay, I just wait and I will get the message back and I continue at that point. It's a completely different mindset, and getting used to that, part of that you can resolve by doing a hackathon for half a day or a day. Let's just translate some code towards a new solution. And another part is do a presentation like this, in which you also talk about the finer details, which brings me to the point, and something in PowerPoint is broken. Accept your worries. It's not fear. A worry is fine. Everyone has worries about stuff. Fear is bad because it will stop you from doing things, but worry is just accepting that something might happen that you don't want, or that's unexpected. And once you accept it, you can start working on it, and you can start experimenting and adapting and improving upon it. And in the end, you will have wonderful code that's perfectly performing and also quite readable, because a lot of code we had in the past was just built, hacked in over time, over the past 3 years. And after a while, those methods start to become bigger, and those names start to become more unclear, like, what am I actually doing here? Migrating towards the reactive framework helped us also to better clarify what our code was doing, what was expected, and what we resulted in. And in the end, making our life better, but also delivering better code. That's it. Any questions? Yep. Mm-hmm. Yeah. So the question is, did you ever apply it to a domain-driven design? Yeah. We didn't, unfortunately. I do like DDD, but we used an existing platform that was already quite well architectured. So the step for us was quite easy. We did the migration from microservice to one monolith back before. That was like 1 day of work, and it's done, it's working, all the tests are still fine. So the migration towards Reactor also went quite easy for us. If your code has a lot of legacy code in it, or stuff built before by another team, then it might be more difficult, and I think you should first clean up your code to a clean architecture, and then on that build on with Reactive. No matter if you use Project Reactor or any other Reactive framework like RxJava, etc. Any other questions? Yes? Can you walk a little bit forward?
Let's say you are processing the message in the fax,
Mm-hmm.
container your Java machine crashes, yeah?
Yeah. Yes, so the question is, what do you do when the machine crashes that you're processing the reactive message on? That's actually one we discussed with our management. Like, is this acceptable for you? Because if it crashes, we lose it. That's mostly happening when you do containers. If we crash now within our chain, we do have the on-error resume, on-error continue. If we do the on-error resume, we know what we are. We already have a copy of the message we already had. We can still keep it and then retry later on once that issue is resolved. If a complete container or JVM crashes, yeah, that's a big issue that you cannot at that point handle. But that's the same when you process a normal request. We don't do any, it's all stateless. So this is not a reactive issue, this is more of a statelessness issue. We asked them if this was okay, and if not, then we would have added some state within our application. Yes?
Did you try Kotlin coroutines? Because it's very simplified this reactive.
Yeah. So the question is, did you try Kotlin coroutines? We did actually play with Kotlin. We migrated our application in, I think, also a day, and then with the auto-migrate tool, and then fix some stuff so it looks readable. Coroutines are quite promising. I also use them in Android. However, for us, that would be too big of a change. And what we're also running into is that a lot of developers within the Netherlands, at least in the north where I'm from, they don't know Kotlin. Some students do, but most of the people using Kotlin within our company are using Android. And yeah, you can ask them to join us, but it's a big step up if you can just say, I want a Java engineer, you hire him, and oh, you also have to learn Kotlin. So that's why we didn't try it out.
I can say about our experience. So in our team we use Java and Spring Boot, and when we started using Reactor Reactive approach, we created this microservices using Kotlin because we see a lot of benefits. And even this transformation from this programming, reactive programming paradigm in Java, even quite easier, I would say, in Kotlin using coroutines. This could be even easier.
Yeah, I really like Kotlin. So, like you also mentioned, some parts are much easier in Kotlin. However, if I look at our application, can I go quickly back? All the way back? No, it takes a long. We already had completable futures, and at that point, you could replace those with the coroutine. That would make sense. But we've also completely reactivated or fluxed our entire processing chain. So from the beginning to end, if you call our API, until the answer that you get back by all those services, that's all reactive now. And that change will be quite big. Those are things we sometimes do as a Friday afternoon chapter exercise to do proof of concept, which is what we also did by translating the application to Kotlin. Any other questions? And I would like to thank you for your time. I hope you also enjoyed the conference, and I hope to see you next year.